Students, in this video we are going to discuss about the dielectric or insulator. So already you know what is in the insulator. Okay, the insulator is one of the non-conductive material. So if you know the example, easily you can understand what is in the dielectric. Okay, the dielectrics or insulator, the example for the dielectric is glass. Glass is one of the example for the dielectric. Ebonite and mica sheet. These are the example for the dielectric or insulator. So now easily you can give the definition for the dielectric. What is meant by dielectric? Dielectric means it is the non-conducting material. So in this type of material there is no free electron. So non-conducting material means it does not conduct the current. So which material it does not conduct the current? Here, if there is no free electrons in a conductor, that conductor is not conduct the electric current. So what is in by dielectric? Dielectric is one of the non-conducting material. There is no free electron. Here, why there is no free electron means all the electrons present in this material, it is directly bond with the atoms. Directly bond with the atoms. So there is no free electron in this conductor. So this type of material is called a dielectric or insulator. Example for that is glass, ebonite and mica. So when the electric field is applied to this type of conductor means the electrons are not free to move anywhere, but that electron is realigned in specific way. So a dielectric is made up of the either polar molecule and a non-polar molecule. It is classified into two types: the polar dielectric, non-polar dielectric. Okay, so first we are going to discuss about the non-polar dielectric. So what is in the non-polar dielectric? In this type of dielectric material, here the center of the positive charges and center of the negative charges are in same. The center of the negative charges and center of the positive charges in this material is the same. This type of material is called non-polar molecule or non-polar dielectric molecule. So when the external field, there is no external field. So this type of material, when the external field is applied, when the external field is applied means here this center of the positive charges is also having some space with the center of the negative charges. So like this here we consider when the electric field is applied, when the external field is applied, the center of positive charge and the center of negative charges are separated by the small distance which is induced the dipole moment. So already we know what is the meaning for dipole. Dipole means it equal opposite charges are separated by the small distance. So when the external field is applied means in this type of non-polar molecule there is also induced the dipole moment. So this dipole moment, it has a direction is along with the external electric field. Then this dielectric is said to be polarized by the external electric field. Polarized by the external electric field. So now we are going to discuss about the polar molecule. So what is the meaning for polar molecule? In this type of polar molecule, here the center of the positive charges is always separated from the center of the negative charges. So even in the absence of the external electric field, here the center of the positive charge and the center of the negative charges are separated. So here we consider naturally in this type of polar molecule, there is also having electric dipole moment. There is also having the electric dipole moment. So for the non-polar molecule, there is no electric dipole moment. Okay, so the polar molecule, there is also having the electric. So this electric dipole moment having the direction in random direction. So in a polar molecule, we consider there is also having the dipole, one positive charge, one negative charge. Here the center of the positive charge and the negative charges is also separated. So here you notice that here it is moves in random direction. It is moves in random direction. So you can calculate the net dipole moment for this polar molecule is 0 because it is moves in random direction. So the net dipole is 0. When the external field is applied means here this type of dipole inside the polar molecule, it is orient themselves and it is arranged in same direction. So when the external field is applied means here this dipole, it is also arranged like this. Plus minus plus minus plus. Okay, it is arranged like this. So like this here we consider now this dipole moment is induced when the external field is applied means the dipole moment is induced by the external electric field. Then the dielectric is said to be polarized by the external electric field. Okay students. So now we are going to discuss about the important one more, that is example for the non-polar molecule. What are the example? The hydrogen, oxygen and carbon dioxide. These are the example for the non-polar molecule. For the polar molecule, it has examples, that is water, nitrous oxide, hydrochloric acid and NH3. These are the example for the polar molecule. These are the example for the polar molecule. So by using this concept, we are going to give the definition for the polarization. So what is in the polarization? The polarization is defined as the total dipole moment per unit volume. The total dipole moment per unit volume is called a polarization. The polarization is always directly proportional to the applied electric field, that is external electric field. So we can write the polarization is one of the vector quantity. P vector is directly proportional to the external electric field. So P vector is equal to means we want to give one constant values, that is one of the psi E. So P vector is equal to psi E external. So here what is psi? It is one of the constant, that is a constant of proportionality. Here it is called the electric susceptibility. Electric susceptibility. Okay, it is one of the characteristics for the dielectric material.